Today, we'll be talking about Isaac Newton's third law of motion. The third law of motion states, for every action force, there is an equal and opposite reaction force. This means that when two objects interact, there are a pair of forces acting on each object. The size of the forces on the first object will equate to the size of the force on the second object. These forces will then propel each object in the opposite direction they were initially heading. Here are a few real-life examples that demonstrate this law. When a ball hits the ground, the ball's force impacts the ground. In return, the ground hits the ball back, equally in the opposite direction, so the ball bounces off the ground instead of staying there. When a bird flies, its wings push down on the air. In return, the air pushes back up, equally in the opposite direction, allowing the bird to stay in the air instead of falling. Here is a quick demonstration using two basketballs to demonstrate the law. By throwing the basketballs with the same approximate force towards each other, the reaction force will propel each basketball away from the point of contact and land at approximately the same distance from that point of contact. Here are some experiments to see which factors of the objects would affect the third law of motion. First, we use two tennis balls to test if the size of the objects matter. Evidently, the size of the objects do not matter, as when the two tennis balls hit each other, the propulsion force propelled both tennis balls in the opposite direction, an equal distance away from the contact point. As this is the same result as the larger basketballs, it proves that size does not matter when talking about Newton's third law of motion. In this experiment, we tested two balls of different weights, a basketball and a tennis ball. As you can see, the reaction force from the tennis ball was not enough to counter the mass difference between the two balls. Therefore, the basketball was almost not affected by the impact from the tennis ball. In the next experiment, we tried a volleyball and a basketball. As you can see, the volleyball's reaction force is greater than the tennis ball's reaction force from the previous experiment, since when the volleyball had hit the basketball had stayed at the point of contact due to the reaction force that the volleyball provided, whilst the volleyball went flying in the opposite direction that it came. In this final experiment, we tested if density matters just as much as mass, as a volleyball is much less dense than a tennis ball. But as you can see from the experiment, the volleyball propelled the tennis ball much farther than the tennis ball did to the volleyball. Therefore, density does not matter when considering Newton's third law of motion. In conclusion, from these experiments, we can tell that neither size nor density matters when we're talking about Newton's third law of motion, as it all comes down to force. Force equals acceleration times mass, of which density nor size is seen in the equation, therefore rendering them useless when talking about Newton's third law of motion. A common misconception is that if there is an equal force acting on each object in opposite directions, then there should be no force. There is motion because the forces do not cancel out each other. Rather, if two objects impact each other, both will move in opposite directions, unless an object has a large enough mass not to be forced in the other direction. This is due to how acceleration is inversely proportional to force and is lowered by an increase in mass. Thank you for listening, and here are the outtakes of how long each experiment took in times 20 speed.